here. So he said that just like in the free expansion of the gas when we were discussing in free expansion in the 18th chapter. So what we the free for free expansion we have discussed about a example in which we have a gas in one chamber and in other chamber there was a vacuum. So what happened that when we open the vacuum, the system, the gas from the chamber one goes into the chamber two until an equilibrium get attained. Means that the pressure of the both containers or the chambers become same. Okay, so the system goes from the initial state I, which is mentioned here. Just a second. Uh, a second. Uh, this is the initial system, okay? Initial state, and there is a gas in this chamber. Obviously, there is a vacuum in this chamber. Okay, so when we open the stopcock from here, so what will happen? Obviously, gas will flow from this chamber to vacuum. Okay, it will move up to the point when the pressure of the both chambers become same. Okay, so at that time equilibriums will get attained. Okay, so this system goes from initial state to the final state. So this is the F state or the final state. At this point, what is happening that now the pressure in both the chambers are same. So the volume of the gas increased while the pressure decreased here in this case, keeping the temperature constant. So this is the initial state. Gas goes from the initial state to the final state through the free expansion. Okay, so this is the irreversible process. Why it is irreversible process? Because now you cannot move the gas from this chamber back to this one without utilizing any heavy source. Okay, there is a chance that you can move this gas to this one, but again you have to do some complex utilization of the thermodynamics in order to move it back. So this sort of the process basically is what it is doing. It is basically we are creating the irreversible process in this scenario. Okay, so this is what this is. This is sort of the entropy, which is also a reversible process. So we will discuss later on that how entropy will increase or how we can define the entropy with respect to this one. Okay, so the PV plot for this graph is given by in the, just hold on a second beta admit kar raha hu kisi ko. The PV plot here, you can see here that it has been given with respect to obviously pressure and volume because we call it as a PV plot. So you can see that at the starting point, at the initial stage, the pressure was higher while the volume was lower. So when you open the stopcock, so what is happening? Gas is flowing to the other chamber. So as a result, pressure is decreasing while volume is increasing here. Now we usually call that K, okay, pressure and volume are basically state properties. Okay, what does mean by the state properties? How you define this state property?
Sir, they depend upon the state of the system.
No, basically state properties means that they are path independent. मतलब, it does not happen on which path they followed. There are different paths that right now they can follow. Like here, they can move up to this point. They can move straight to this point. They can move like this one. They can move like this one. So basically, they are path independent. State properties means that it does not matter how they reach to the final state. Okay? So basically, they are path independent. So now we want to know if these are the state properties. So what are the other state properties like temperature and the energy? And what about the entropy, whether it is a state property or not? Obviously, it is a state property. It is
Yes, sir.
also path independent. Now, this process you can see here that in each and every setup, I have mentioned three possible ways by which the system can go from initial stage to the final state. One is this one, other is a straight one, third one is this one. For each and every process, entropy will increase. So it means that it is not a path dependent. Okay, it should go like, okay, it should go straight, so it will increase. No, it's not like that. Whichever path it will follow, the entropy will always increase. So it means that it is also a state property. ठीक है, means that it is path independent beta. ठीक है, you should always remember. So we can define the change in entropy during a process like we discussed in the upper case, in which the gas flows from the chamber to there. So in this sort of the process, the change in entropy can be written as like this one. Okay, final entropy minus initial entropy. It is dependent upon the heat and that of the temperature. Okay, again, the interesting thing is that it does not depend upon the pressure and the volume. It only depends upon the heat transferred or the absorbed by the system and that of the temperature. Okay, so the temperature is of the system in Kelvin. So uh, entropy does not only depends upon the, like I said, heat, energy transferred as heat, but also depends on the temperature. एक second. But also on the temperature at which the transfer take place. ठीक है, so temperature will always be positive. ठीक है, in this scenario temperature will always be positive. So obviously the sign of delta S, and we also know that heat always heat cannot be negative because it is a form of energy. So for overall sign for this equation will always be positive. So when it always be positive, it means that entropy will always increase. So because positive means that it will always increase. So the unit for this change in entropy is basically joule per Kelvin. So is this clear to you?
Yes, sir.
Okay. कहता है कि नो प्रॉब्लम क्या है कि फ्री एक्सपेंशन इन द फ्री एक्सपेंशन, ठीक है, pressure, temperature, volume of the gas fluctuates unpredictably. ठीक है, you cannot say that there is an equilibrium at any instant. Suddenly they will change and they will attain equilibrium at the final stage. ठीक है, so for the intermediate stages there should be some equilibrium, but we cannot say okay there was an equilibrium or not, because it had this pressure and the volume of the gas changed unpredictably. Okay beta, funny thing is कि बेटा मेरे साथ कह लें कि आवाज आ रही है बेटा? आर यू गेटिंग माय वॉइस?
Yes, sir.
Yes, sir.
अच्छा, अब प्रॉब्लम ये है कि नो आई एम ऑन लैपटॉप मोबाइल व्हाइल माय लैपटॉप गॉट शट डाउन. ठीक है, सो इट विल टेक टाइम टू रीबूट और रीस्टार्ट. मुझे नहीं पता चला, मतलब इट वाज अपडेटिंग एंड सडनली इट गॉट रीस्टार्टेड. तो बेटा जस्ट होल्ड ऑन अ सेकंड सो आई कैन rejoin the class. It will take time. अब मेरे पास स्क्रीन भी शेयर नहीं हो रही. So can anyone share the screen? कर सकते हैं आप लोग?
Yes, sir.
जरा करें. मेरा ख्याल है कि maybe I have changed the settings of this class.
Sir, आप
सर
share
ओपन है, शेयर स्क्रीन ओपन ऑप्शन है.
आप ओपन करें, शेयर हो सकती है.
नहीं सर, उसके ऊपर लिखा रहा ओनली द होस्ट कैन शेयर दिस।
No, I think it was a closed system. ख्याल है?
सर होस्ट में बन गया हूँ, पता नहीं कैसे।
चलो मुबारक हो, शेयर करो यार, किस्मत वाले हो। शेयर कर दो यार। नेक्स्ट लेक्चर आपको अब्दुल हसीब देगा जी, रिमेनिंग। ठीक है अब्दुल हसीब?
नहीं सर, आपकी जगह नहीं ले सकते हम।
नहीं नहीं नहीं, आप ले लो, मुझे कोई एतराज नहीं है, मेरा लोड थोड़ा सा कम हो जाएगा।
सर हसीब पढ़ेगा तो पढ़िए हमने फिर।
हम्म Here it is.
इसे देने दीजिएगा।
चलें, गुड हो गया बेटा। ओके, सो अब we were discussing about the phenomena that we will not be able to find out. Okay, we will not be able to find out whether the intermediate stages have the well-defined equilibrium or not. So for that purpose, what we will do is कि क्या करेंगे हम लोग ये करेंगे कि we will take that process in which we do know that during the intermediate stages there was a well-defined equilibrium, and what does it means that we will be able to trace the values of the pressure and volume in between the intermediate stages. Now in this sort of the नहीं बेटा, ये अब आपको इस तरह गैस नहीं होगा, क्योंकि मैंने थोड़ा सा स्क्वायर वगैरह से आपको बताना था, लेकिन वो नहीं होगा। जस्ट करें, रीस्टार्ट हो गया, जस्ट होल्ड ऑन सेकंड बेटा।
सर जी टाइम हो गया, नेक्स्ट पे रख लें।
टाइम अभी 10 बजे नहीं है क्लास आपकी नेक्स्ट?
सर नहीं, आगे आगे थोड़ी लेट है।
तो 5 मिनट बेटा देख लेते हैं, ये एंड कर लेना बेटा, फिर नए सिरे से दोबारा शुरू करना।
यस सर, वैसे आपको होस्ट बना दिए थे इस मीटिंग में।
बना दिए बेटा? चलो
यस।
चलो, फिर तो गुड किया आपने। ओके, अब यार अब मैं होस्ट बनता हूं तो या तो मैं आदी हुआ हूँ लैपटॉप का, शायद इसलिए
यस
एक एरो मूव करना जो है ना मुश्किल हुआ है। एक सेकंड, समटाइम्स अचानक की प्रॉब्लम्स होते हैं। अच्छा, पेपरों का क्या बना?
अल्हम्दुलिल्लाह सर, होपफुली अभी ईद के बाद होंगे।
अच्छा, well, schedule up to I think 30th April तक, and afterwards they were saying कि
बताएंगे।
yeah, they will release it, but up to 30th April you are off, ठीक है? So most probable I would like to have the exams after Eid, मतलब
इंशाल्लाह।
रमजान के बाद it will be quite easy. The other probability is that like in your like your senior section 2019 they have given the combined mid and final term exams, ठीक है? So the combined mid and final term exam was of 70 marks, ठीक है? So probability can be like this one, ठीक है?
फर्स्ट सेमेस्टर में हमने ऐसे दिए थे मिड और फाइनल इकट्ठे।
नहीं, हमने कॉम्प्रिहेंसिव नहीं दिए थे, हम लोगों ने
लेकिन इकट्ठे
कॉम्प्रिहेंसिव
ही थे
दिए।
ना, साथ साथ थे हमारे।
सर कॉम्प्रिहेंसिव काफी मुश्किल हो जाता है।
अच्छा चलो यार, वो मुश्किल तो होता है, बट अगेन मतलब it was
समथिंग इज बेटर देन नथिंग सर।
एग्जाम्स तो होने हैं, इट इज श्योर, मतलब एग्जाम इट विल टेक प्लेस, ठीक है, लेकिन अच्छा
इसका
जी।
मतलब 30 अप्रैल तक हमारे पास एक मिड्स का स्लिप्स कवर करने का टाइम है।
हम्म। नहीं 30th अप्रैल तक सिलेबस नहीं बेटा, सिलेबस इतनी जल्दी कहाँ कवर होगा, फ्रॉम
तो मिड्स
19th
का
अप्रैल। नहीं मिड्स का तो आपका ऑलमोस्ट अब कवर्ड है, दिस इज द देयर इज वन मोर लेक्चर, ठीक है, सो 3 chapters will be covered for your midterm exams, okay. After that, what we will study for the final term, ठीक है, but the thing is that if there is mid going to take place after Eid, so I think that there I will give you 4 chapters as a for the midterms, and then the remaining chapters will appear as a final term.
सर टोटल कितने चैप्टर हमने पढ़ने हैं?
जी बेटा, टोटल बेटा हम लोगों ने पढ़ने हैं almost we will study around about 7 chapters. कोर्स आउटलाइन में कितने हैं आपके?
कभी खोल के देखा ही नहीं है।
मुबारक हो बेटा।
सर आई थिंक 8 है।
8 है।
अच्छा 8, 2 के ऊपर तो आपका स्टार लगा होगा, मीन्स दैट स्टार मीन्स के टेंटेटिव होंगे कि मतलब मोस्ट प्रोबेबल आपका कोई एक आध चैप्टर रह भी जाए तो इट डजंट मेक ए डिफरेंस, बट होपफुली वी विल बी एबल टू कवर देम, ठीक है। So when we will be able to cover them, so obviously we will and they will be a part of your course outline, ठीक है। जितना मर्जी स्लो चलो, but it means कि
बस चलें, ठीक है।
we are going fine, ठीक है। So okay, so now I am sharing you the screen, ठीक है। So now I am into the play, ठीक है। So अब कहाँ पे हमने लेफ्ट किया था वहां से we will start it, ठीक है। चलें जी। अच्छा, नो व्हाट इज द प्रॉब्लम के प्रॉब्लम ये है कि व्हाट वी वर सेइंग कि ओके जी अनप्रेडिक्टेबली है, अनप्रेडिक्टेबली क्या है कि वी वर नॉट एबल to find k in between the stages what was the pressure, what was the, let's suppose we are saying it is a state property, so it means that obviously it can follow any path. So when it can follow any path, we will not be able to find out k at what stage, let's suppose after the whole process took 10 seconds, so what was the pressure and the volume after 2 seconds, what was the pressure and the volume after 4 seconds. So it means that we will not be able to trace the path properly, okay. So obviously for that purpose, if we are not able to trace the path properly, so since we are using the integral I to f, so we will not be able to find out the exact value of heat or the temperature in between the stages, and therefore we will not be able to find out the sorry, change in the entropy. Okay, so for that purpose, what we have to do, okay, we have to suppose a process, okay. We will replace the reversible process with the reversible process, and we will take that process in which we are able to find out the past. Let's suppose okay, and just hold on a second. Let's suppose I am assuming this is the path that it followed. Now, each and every point, I do know that what would be the value of the I and what would be the value of the F during this path. So I can trace the value of the pressure and that of the value of the path. And as a result, I will be able to get the value of the or the relation between the Q and T in order to find out the entropy changes. Okay? So is it clear? Okay, should I repeat it?
सर एक दफा करते हैं रिपीट प्लीज।
Okay. This is the process. मतलब originally this was the process. We have a chamber container. ठीक है, one container was filled with gas, other was empty. So gas moved from the filled chamber to the empty chamber, and the only thing that we know that is that initial stage the pressure and volume was this one, and at the final stage the pressure and volume was have certain value. So in between the process, because it was an abrupt process, we do not know okay which path it followed, what was the value in between. ठीक है कि whether it was मतलब at after 2 seconds what was the value of the pressure and volume, because it changed unpredictably, it doesn't change uniformly. So we need a process in which we can find out the value at each and every point if we want to. Let's suppose if you want, okay, what would be the change in entropy after 2 seconds, what would be the value of the change in entropy after 4 seconds. So for that purpose we need a process in which we can trace the value of the pressure and volume. So let's suppose that I have drawn this path. So this is the path that is showing that this is the path followed by the system to reach from the initial stage to the final stage. So in between, after 5 seconds, I do know that after 5 seconds the process would be at this point, ठीक है, and the pressure and volume would be this one. So now I can trace the pressure and volume. When I can trace the pressure and volume, I will be able to find out the value of Q and T. So when I can find out the value of Q and T, so then I can also find out the value of the change in entropy. So now it is clear to you.
Yes.
ठीक है. So coming toward the next, what he's saying कि अच्छा अब क्या है कि the process for मतलब let's suppose the process which I was telling you कि हमने follow किया. Now this is the process which he is defining here. This is the isothermal process. So isothermal process, this is the process he was telling कि now what is the isothermal process? Obviously isothermal process is the process in which you keep the temperature constant. Okay, so how you can keep the temperature constant? कैसे करते हैं आप टेम्परेचर कांस्टेंट? इफ यू आर एक्सपेंडिंग द गैस, ठीक है, ये आपके पास प्रोसेस है, ओहो, ये आपके पास एक चैम्बर है, ठीक है, there is a gas confined within the system which has certain pressure, ठीक है. So when you will remove the lead shots or the weight from the top of this cylinder, it will expand. When it will expand, in order to maintain the pressure, obviously volume will expand. In order to maintain the temperature, what will happen that it will absorb the heat from the thermal reservoir. So when it will absorb the heat from the thermal reservoir, it will keep the temperature of a system constant. But during the process, what is happening that pressure and volume both are changing. So this is the isothermal process which we already have studied in chapter 18 or 19. Okay, so this process clear to you? Any question for this process? Okay, I think there is none. No, this process is explained by this is the reversible isothermal process. Now you can see that it is following a certain path. ठीक है, at a constant temperature, it is following a certain path. Now, each and every step we do know that what would be the value of the pressure and volume, means that we can trace the pressure and volume at each and every point of the process, ठीक है, during its expansion. So in between the initial and the final state. So it means that then we can find out the value of the heat transferred. And since it is a constant temperature process, so obviously we do note the value of the temperature too. So as a result, we will be able to find out the entropy or the change in the entropy of a system. ठीक है. So कहता है कि the irreversible क्या है, कहाँ पे है, क्या कर रहा है? अच्छा ये है. No, this is the reversible process, okay, because it can trace its steps back to the initial stage. So the reversible isothermal process is different from the irreversible free expansion. Okay, how it differs because in the here see you can see here that in the I will just draw the points here. Just hold on a second. In the free expansion process, this was the same states were I was the initial state and F was the final state. मैंने इसको ज़्यादा इसलिए ड्रॉ किया ताकि आपको थोड़ा सा अंडरस्टैंडिंग हो. So they both were the same, ठीक है? But the process, the only difference is that in between the paths we were not able to trace the path for the pre-expansion, but in the isothermal process, we can trace the path between the initial stage and that of the final stage. बेटा मुझे 2 मिनट देते हैं, just 2 मिनट दीजिएगा बेटा.
Shoots. रिकॉर्डिंग हो रही है.
Are you getting my voice?
Yes sir.
Yes, sir.
सर
Okay,
रिकॉर्डिंग
fine.
हो रही.
यार मुझे पता नहीं है, मैंने देखा नहीं है. पास शेयर
शो तो नहीं हो रहा.
शो नहीं हो रहा बेटा, नहीं हो रही. ये वाला स्टॉप. चले अभी कर लेते हैं. किस्मत आप लोगों की. यार आई थिंक यू डू हैव ए ऑप्शन ऑफ रिकॉर्डिंग.
सर लेकिन
can
आप
also each and
वो
every-
आपने परमिशन अलाउ करनी होती है.
Yes, the host.
I think I have given the permission. Have you tried?
नो सर परमिशन नहीं है हमारे पास.
Okay, from next time I will give you the permission. Okay. मेरा ख्याल था
Yes.
I have given you the. Maybe there is another class for which I have given you. I have given them. ठीक है. So for isothermal process, what we can do is we can utilize the equation which we have previously used, which is 21. So for this process, the equation is the same one. Why we have taken the temperature out of the integral? Because in the isothermal process, the temperature was the constant one. Okay. So, अच्छा, अब reason क्या है कि why we are previously we were discussing about the free expansion, and here we discuss about the isothermal process. So the reason is in the previous case that the gas was fluctuating unpredictably. Okay, so we only do know about the initial stage and that of the final stage. It means that we do know about the I and the F. In between, we were not able to find out what would be the process, how, and therefore we will not be able to find out the temperature and data of the heat. So what we have done is that we have replaced the free expansion with the reversible isothermal process. Now, in the reversible isothermal process, we do know the path which it is following, and the both I and the F state of both the processes were same. So we can utilize the reversible alternative reversible process to find out the change in entropy of the irreversible process. Okay, so this is what we have done. So that's why in the free expansion we cannot utilize the equation because we are taking the integral from I to F. So we have replaced it with the isothermal process, which is reversible process. So, and then we trace the processes in between the initial stage and that of the final state, and then the change in entropy because initial and final state is the same one. So by replacing it, we will be able to find the value of change in entropy, and that value would be the same as that of the irreversible process. Okay. So taking T constant, so overall the heat energy transferred during the process is Q. So we will use this one. So overall change in entropy is equal to this one. Okay. So this is the amount of the energy. Let's suppose if we have taken 300 Kelvin and 20 joule was energy was transferred. Okay. So we will be able to find out the exact value of change in the entropy. So overall, we can summarize the whole lecture into this point. Okay. In order to find out the entropy change of the irreversible process occurring in a closed system, we will replace the process with any reversible process that connects the same initial and final state. Okay? So when we will calculate the entropy change for this reversible process, it means that it will have a same value as that for the irreversible process. So initial and final state means कि क्या है कि let's suppose this initial state has the pressure of 2 bar, final state has the pressure of 4 bar, initial stage has the volume of 2 liter, final volume was the 4 liter. So in the previous case, in the pre-expansion, if the values are the same for I and that of the F, then obviously we can say that the change in entropy for both processes was same. So actually we have replaced the irreversible process with the reversible process and with same parameter, same initial and the final stages. Okay? And then we calculated the change in entropy. We cannot calculate the change in entropy for the irreversible process or the process where the values are changing unpredictably. Okay? मतलब we do not know whether it is changing at abruptly or it is changing slowly, or at sometimes it is changing abruptly and sometimes it is changing slowly. So we only do know about the initial stage and the final stage.